The functions of the RLC sublayer are performed by RLC entities configured peer-to-peer in the eNode B and the UE. It communicates with the upper layer PDCP through a service access point and with the lower layer MAC via logical channel. The main functions of the RLC are passing SDUs from PDCP to its peer via the MAC layer, formed into PDUs. Receiving PDUs from MAC, extracting the SDU information and passing it up to the PDCP. Reordering of PDUs. RLC SDUs can be variable in size and are byte-aligned, i.e. multiple of 8 bits. An RLC PDU is formed only when a transmission opportunity has been indicated by MAC and then delivered to MAC. An RLC PDU can be an RLC data PDU or an RLC control PDU. It is the RRC layer that controls the configuration of the RLC. An RLC entity can be configured to transfer data in 3 modes: transparent mode, unacknowledged mode, acknowledge mode. In transparent mode, the transmitting TM-RLC entity will submit an RLC SDU without any modification to the lower layer. When receiving, the same applies for the upper layer, no modification. When transmitting in transparent mode, there will be no segmentation nor concatenation, and there is no header included. So a AMD PDU consists only of a data field and does not include any RLC headers. Therefore, the usage of transparent mode is very restricted. Only RRC messages which do not need any RLC configuration can be transmitted in transparent mode. These messages are broadcast information, paging, and RRC messages sent on Signal Radio Bearer 0, SRB0. Transparent mode is not used for any user plane data transmission. The Unacknowledge Mode transfer service is unidirectional and is mainly used by delay-sensitive and error-tolerant real-time applications. When transmitting, the UM entity will perform segmentation and/or concatenation on the RLC SDU from the upper layer. The size of the formed RLC PDU is indicated by the lower layer, MAC. The formed RLC PDU is byte-aligned and without any padding. When receiving, the RLC Unacknowledged Mode entity will reorder the received information if it is received out of sequence before delivering to the higher layer PDCP. The Unacknowledged Mode header consists of a fixed part and an extension part. The fixed part includes framing information, an extension bit, and a sequence number. The extension part of the header includes ease and length indicators. The extension header is present when more than one data field element is concatenated. An E and a LI are present for every data field element except for the last. The Acknowledge Mode transfer service is bidirectional and is mainly used by delay-tolerant and error-sensitive non-real-time applications. When using the Acknowledge Mode, the entity is configured with the ability to both transmit and to receive. The transmitting Acknowledge Mode entity will perform segmentation and/or concatenation on the RLC SDU from the upper layer. In addition, the RLC peer will acknowledge the received data PDU using another type of PDU called a status PDU. The status PDU will indicate the lost data PDUs to the transmitter so that they can be retransmitted. But since the radio conditions may deteriorate during the retransmission procedure, the lost PDUs may have to be broken up into smaller segmentations, resegmented, before the retransmission. The header of the RLC data PDU consists of a fixed part and an extension part. The fixed part includes data control bit, resegmentation flag, polling bit, framing information, extension bit, and sequence number. The extension part of the header includes ease and length indicators. The extension header is present when more than one data field element is concatenated. An E and a LI are present for every data field element except for the last. A status PDU consists of an RLC control header and a status PDU payload. The RLC control header of data control bit and control PDU type field. The status PDU consists of one section for indicating acknowledgement of a set of AMD PDU and another section for indicating AMD PDUs within the set which are not acknowledged. If the control PDU is used for ACNAC of received AMD PDU segments, the SO start and the SO end field is utilized. Since all AMD PDU segments have the same sequence number, they are separated by their position in the original AMD PDU. The header of the AMD PDU segment consists of a fixed part and an extension part. The fixed part includes data control bit, resegmentation flag, polling bit, framing information, extension bit, sequence number, last segment flag, and segment offset. The extension part of the header includes ease and length indicators. The extension header is present when more than one data field element is concatenated. An E and a LI are present for every data field element except for the last. Let's go through an example. It is the base station that is the transmitter. starting with an RLC PDU with two PDCP PDUs concatenated. The base station will store it in its RETX buffer until acknowledged. The UE will deliver this information up to the higher layer, PDCP. The second transmission includes a segment in the beginning and one in the end. This packet is lost. The base station continues the transmission, but this time it indicates, with the polling bit, that it wants to receive a status message from the UE. The UE will store the message, number 3, in its RX buffer until PDU number 2 is received correctly. The received PDUs are always delivered to higher layers in correct sequence order. These three transmissions are examples of RLC AM data PDUs. The UE answers with the status PDU, indicating that it is ready to receive next RLC PDU with sequence number 4. But the UE also indicates that the RLC PDU number 2 is missing. Now the base station can remove number 1 and number 3 from the RETX buffer and prepare for retransmission of number 2. But during this time, the radio conditions have changed, so that retransmission requires lower modulation. So the original RLC PDU now has to be split into two retransmissions, two AMD PDU segments. The two headers will indicate that this is a retransmission, and also two segments of the original PDU plus the position of those in the original RLC PDU. In this example, the first retransmission is lost, and the UE will ACNAC on this.